Now, we have been doing graphing by intercepts, okay? Fairly straightforward process. Pick an example that I think will be nice. Well, you know what? Have we gone over 48 in class yet?
Wasn't that a sign?
I think it was a sign. I'm not sure if I went over it with everyone, but let's all go over it again with Alex, just to be sure.
Yeah.
Okay? So the goal here is to graph by finding the x and y intercepts. There's a lot of ways to graph this. Reed the other day started doing it. He forgot, had a little brain fart. He started doing it the way we did on the midterm with making 5 points. Normally that's not a problem. You were doing it very well, as I recall. But we want to do it just by finding the intercepts. And your key to know if you're doing it the right way is if you remember that you are trying to fill out this specific table. All right? Now, how do we fill out this table? Well, for the equation y equals 5x plus 15, this 0 in the table that is under the x, okay, that means put a 0 in for x and find the y. So to do this first part, we are going to take this 0 here and we are going to put it in for the x coordinate. And we're going to solve that for y. Hey Zoli, what's 5 times 0? 5 times 0 is 0 indeed. So I don't have to write that. And y just equals 15. Hey look, I'm done solving. I'm actually done solving. If x is 0, y is 15. It's not just a solution to an equation, it is a point on a graph. Now, I'm not going to draw the graph yet because, remember I said, fill in your table first because right now you don't know how much of the graph you need. For example, if you printed out graph paper that only went up to 10 on the y-axis, that would not help you on this. Does that make sense? Like I know right now graph paper that only goes up to 10 won't work because this goes up to 15. So next step, I'm going to take this 0 here, which is a y value, and I'm going to plug it in for, I'm going to write the y, so I'm going to plug it in for y in the same equation. Y equals 5x plus 15. I am going to put a 0 right there. So the equation I get just looks like 0 equals 5x plus 15. You guys find it a little weird to solve equations when it's 0 on one side?
Yeah.
Yeah, it's kind of weird looking, but you still have the same goal and the same steps. Your goal is to get the x by itself. And like we've asked before, what is bothering the x? Well, two things are bothering the x. It's being multiplied by 5, and it's got 15 being added to it. Solving an equations, we said, solving equations goes reverse order of operations. Reed had a way to remember that I won't repeat right now because I just remembered. It's not quite video appropriate, but it was clever. It's PEMDAS backwards. It was kind of clever. So first we're going to get rid of the plus 15. So we're going to subtract 15 from both sides. And that is going to give us negative 15 equals 5 times x. Now we're going to divide both sides by 5. And that gives us x equals negative 3. Any questions in here that would help Alex out on how I created this table? Put a 0 under the x. That means substitute 0 for x in the original equation. Put a 0 under the y in the table. That means substitute 0 in for y in the original equation. Solve in both cases, fill in the appropriate amounts. Now I know that my graph only has to go out to negative 3 on the x-axis, but it has to go up to 15 on the y-axis. I'm going to make a new slide. I'm going to make myself some room. I don't need any of this work right now because all I need to do is the graph. All right, guys, quick pop quiz review, whatever. I'm going to regret asking this, you can already tell. Philip, am I going to regret asking this?
Yes.
I am, okay.
I'm not Philip.
What quadrant did I mostly draw here on my little graph?
Upper
Upper which?
first?
It's the upper left.
Yeah.
Which one is it, Zoli?
Quadrant 2.
This is quadrant 2. Very good. On the coordinate plane, the Cartesian coordinate plane, it's the quadrant 1 starts in the upper right, and then it goes counterclockwise, and we use Roman numerals. I drew this graph to just show off quadrant 2, because quadrant 2 is where y is positive and where x is negative. This is northwest DC. This is part of DC closest to Montgomery County where we're standing right now. Northwest is quadrant 2. And guys, if I just say sketch, or you know what, if I just tell you to sketch, graph the equation, you don't have to draw all 15 of them. You can just go, you know what, I'm going to put 15 on the y-axis there. Why on the y-axis? Because that's the point, 0, 15. Goes up 15 on the y-axis. And then on the x-axis, I just have to put -3 around there. And my line just has to connect those 2 points. I don't like the way my line cut through the -3 there, so I'm going to label it this way. You guys do understand that this point here, another way to write that is -3, 0, like on our table over here. Means it goes 3 to the left, then do not go up or down. And another way to write this point is 0, 15, like the 0 and 15 on this row of our table. The 0 means don't go left and right, the 15 means go up. Any questions on this example? Okay, we're going to pause here for a second because our class is about to get interrupted, and we will pick up again in a moment. Cleansing breath. Okay. How does graphing by intercepts help us with word problems, real life situations? Your school drama club is putting on a play next month. By selling tickets for the play, the club hopes to raise $600 for the drama fund for new costumes, scripts, and scenery for future plays. X is the number of adult tickets they hope to sell for $8 each, and Y is the number of student tickets they hope to sell at $5 each. Now, normally the first thing you would do is try and turn this into an equation, but they did it for you. But I want to break down why this works. They gave us the equation 8x plus 5y equals 600. I'm going to sort of mix the math and the English here, and they asked us to graph it, but I'm going to mix the math and the English here. What this actually says is $8 multiplied times the number of adults that they get to show up for a play. Okay, if 5 adults come in, they get $40. If 1 adult comes in, they only get $8. If 2 adults come in, they get $16. If 10 adults come in, they get $80. 8 times the number of adults, that's what the 8x means. Plus $5 times the number of students. If they only get 1 student to show up, they only make $5. If they get 10 students to show up, they get $50. If they get 1,000 students to show up, they get $5,000. That's what 5 times y means. $5 for each student that shows up, plus $8 for each adult that shows up, and their goal is $600. Okay? Does that make sense that that's where that equation comes from? Mm-hmm. All right. And there's a bunch of different ways they can do this. They can get this $600 by different numbers of adults and students showing up. And that's what this line is supposed to help us visualize. So we're going to graph this through our usual fun of making our table. And the only difference now is the numbers are going to be a little bit bigger. Put a 0 for x and a 0 for y. If you put the 0 in for the x, you are once again finding the y-intercept. The row on the table where there's a 0 in the x will give you an x and a y and a point, and that point will be the y-intercept where your graph hits the y-axis. On this particular equation, that is going to be 8 times 0, putting the 0 in for this x, plus 5 times y equals 600. 8 times 0, Zach, what's 8 times 0?
8, no, I'm just kidding. 0.
0. On the second try, Zach says it's 0. 600 divided by 5, I will go ahead and tell you, is, this will get us y equals 120. If anyone wants to double check me with a calculator, that's fine. All right, that's all he said. Yes, Reed?
Do we need to know the number of adults and students?
No, that's the whole point. They're literally, that's what a variable means in this
Oh,
case.
I already determined it.
Yeah, it's whatever. There's a bunch of different ones. I'm sure you did determine 1, 2, 3, 4. There's actually literally an infinite number of numbers that can work, but some of them would be decimals and fractions, which doesn't work for people. But there's plenty of answers. Okay. In fact, believe it or not, this is an answer right here. Read. If you get 0 adults to show up to your play, you have to get 120 students to show up to make $600. All right. That's actually, I think I just answered one of the questions. But let's keep going. Let me stop jumping ahead of myself here. Let's find the x-intercept next. And the x-intercept, I'm going to leave the 8x and do 5 times 0. Philip?
Yeah.
Difficult question here, my friend. What's 5 times 0?
0.
Very good. So that just leaves us with 8x equals 600. And that is going to be,
Can I answer it?
what is it going to be?
All right, let me think real quick.
Go ahead and give you some hints here. You can reduce that to 300 over 4.
9.
You can reduce that to 150 over 2.
I mean, you can just. Oh, okay.
All right. Now we're still just on number 60 here. We haven't graphed the line yet. We just plugged in 0 for the x to find that then that would make y equal 120. And we plugged in 0 for the y and found that would make x equal to 75. So now, we go back here. Oh, hang on. We're going to do that. Let me get rid of most of this. I don't need all of this work anymore. All I really need to sketch the graph is this table. It's a silly way to do this. All right, you know what? At this point, it'd be easier to erase it. All right. The dollar sign did not want to be erased.
It fought hard.
It did. Much respect. Okay, now, I don't expect you for these graphs. These graphs can be sketches. And what a sketch basically means at this point in your life is you don't have to make 120 marks up the y-axis. Okay? Yes, sir?
Knowledge is unswear.
Not yet. All right, talk to me after in a minute. So I don't want you to make 120 marks up the x-axis, up the y-axis, excuse me. 0, 120 is a point on the y-axis. Just put a mark somewhere up high and tell me that you know it's 120. And then if you really want to impress me, our next point, 75 comma 0, this means go 75 units on the x-axis and do not go up or down. Okay, I don't want you to make 75 little marks. Just, if 120 is about that big, maybe make 75 just a little bit less on the x-axis than you made 120 on the y-axis, and it's good. That's called sketching a graph. It's all you need to do for this. And now I just have to connect these two dots, and that's my line. Okay? You guys think you can handle that, even with numbers this big? I'd let you use a calculator when we get into the hundreds, but should be doable. Now, 61. What is the x-intercept? Okay, well, the x-intercept is this point, 75, 0. I just said this a minute ago, but what did I say the x-intercept meant? Anyone remember? Yes. Zoli.
How much money they'll make if how many adults showed up?
Kind of.
Well,
A little bit more specifically. I mean, they're going to make $600 no matter what,
yeah,
the way they set this up.
they're not how many adults. My words are blinking.
Words are, no, this says, yes, 75 adults will show up because X is the adults, right?
Yeah.
They're charging $8.
Yeah.
This says if 75 adults and 0 students show up, you will still make $600. Okay, does that make sense? Any point on this line will work for making $600. Okay, one way to do that is to have 75 adults show up and no kids. For a school, to have no students show up, that'd be pretty bad. Kind of weird if 75 adults showed up and no kid wanted to see this play. That would be a little bit weird. What do you think 62 means? It's very similar to what 61 means. Reed, what do you think?
It means the amount of students.
It's the amount of students you would have to have show up if no adults showed up.
Yeah.
Yeah, so this says if 0 adults and 120 students show up, you will still make $600. All right, now, Reed, you said you found a solution. What did you find?
I found a solution.
Did you say you found something that worked, or did I misunderstand?
I think I did.
Okay.
I'm not sure, but I think it was around 20 students and 40 adults.
Well, here's how we can check.
It was something around that.
If 8 times 40 plus 5 times 20 adds up to 600, then 40 for X and 20 for Y, this is 40 adults and 20 kids. Okay, if this math works, it's all connected, okay?
Actually, no. I think it was 40 kids as well.
Yeah, I think that was about to say, I didn't see this one working out. Good mental double checking there. Okay, let's see if this works.
That does work.
Because 8 times
40 is 320.
Yep, that's 320. Plus 5 times 40 is,
200.
oh, not quite. We're only getting $520.
Or I miscalculated like a small bit.
Yeah, so that's going to be slightly off. What
So-
63 says to do is find 3 possible numbers, and 40 and 40 doesn't work. numbers that are on, okay, so numbers that will let you, this club, earn $600. These three things are connected. They seem like three different things. Combinations of adults and students that will get you $600 will work if they are points on this line and if this algebra works. Okay? It's got to be, if it works with this algebra, if you can plug in your idea, your guesses, it'll work in this equation, then it'll also be a point in the line, it'll also get the club $600. Reed, what's another one?
So basically, wouldn't it still work? We just up the amount of adults because I was aiming for 400 plus 200.
Okay, so 8 times what would get you 400?
8 times 50.
Very good. Okay, so let's try that.
Oh, and then 5 times 10.
So 8 times 50 is 400, plus 5 times 40.
Wouldn't it be 10 though? And then you're trying to get to 600.
Yeah, this is 400 plus 200. Put a check mark over that equal sign. Yes, and this tells me that the point x equals 50, y equals 40 is a point on this line. If it works in the equation, it will be a point on the line and it will be a solution to the word problem. But it's not the only one.
No.
It's not the only one. I can tell you, well, let's see. There are other ones. Well, actually, you guys have another idea that might work? Is there a way to be sure an idea works?
I'm sure an idea works.
Which idea are you sure works?
Maybe like.
Can't say you're sure and then start with a maybe.
Wait. Hold on. Okay, never mind.
All right.
Wait. Okay, I got it.
You got it?
3. So that was 40 originally. So we do 320 again.
Okay.
Then plus 50 something.
All right, so that would be 320 plus 5 times. Here, you know what we can do?
50 something. It's 50 something.
I'm going to show you a trick, Reed. You ready? You guys ready? Philip, Zach, everybody pay attention to this one. Okay. I'm going to put in the 40 for x that you said, and I'm going to leave the number of students as a variable. I'm going to leave it as y. And then you know what I'm going to do, Reed? I'm going to solve for y. So you say, okay, what happens if 40 adults show up? Well, then you get $320. All right, well, how much more money do you need? We're going to find that out by subtracting 320 from both sides.
Oh, yeah. Yeah.
And we're going to get the equation 5y equals 280, right?
Yeah, that's what I was going for.
All right, and how many times does 5 go into 280? Anyone have a calculator handy? You don't have to know this one off the top of your head.
It's 50 something.
You are correct.
Over 400. Oh wait, no, I was thinking 5 times 80 now.
Yeah, this is going to be
56.
56 is correct. So what this means is, if you can get 40 adults and 56 kids to show up, that will also work. It also means the point 4056 is on this line and is one of the solutions. So one way to do this, if it's too much to juggle in your head, pick a number for x, solve for y. Pick a number for y, solve for x. You just have to be careful, not all solutions work. For example, what if you got a decimal like 0.5? Are you going to sell a ticket to half a person? I don't even know what Philip said, but that's okay. I'm not worried about it.
What if if they're really short?
What if they're really short? They still pay full price. Yep, I tell you, it's frustrating, isn't it? All right, guys, we're going to stop here. Hopefully these videos will help our missing classmate and will help you guys later. Thank you very much.